Morning. So we started last time by discussing noisy channel flow control and error control, and we started by stop and wait automatic repeat request. For the disadvantage for stop and wait was if you have a delayed packet or a delayed frame or delayed acknowledgement, so the sender have to wait for a very long time or infinite time until receive an acknowledgement. So to solve this problem, stop and wait automatic repeat request add simple error control mechanism to stop and wait protocol by adding a timer. So once I will send a frame, we will initiate and we will start timer, and after timeout, if we didn't receive any acknowledgement, we will resend or retransmit the frame again. Okay, and in this case, stop and wait automatic repeat request used sequence number of modulo 2 to transmit the frames and wait for the acknowledgement. And we take the design. We have 4 events in this case, 3 at the sender and 1 at the receiver. And we discuss the code of stop and wait automatic repeat request. Okay, and start by 2 examples. If we need to send 3 frames, first one received correctly. So I will, after receiving acknowledgement, I will stop the timer and start a new one for frame 2. But frame 2 get lost, so I will wait for timeout, then resend frame 1 again and make acknowledgement. For frame 3, the acknowledgement will get lost. So after timeout, I will resend frame 3 again. And in this case, it will be duplicate at the receiver side. So it will be discarded. But from the sender, I didn't receive acknowledgement, so I have to retransmit it again. Okay. Okay. Now we stop here at this example. So starting from this example, this example shows the disadvantage of stop and wait automatic repeat request and why we need to move to another protocol. In this example, we assume that the bandwidth of a link is 1 megabit per second. Okay, and 1 bit take 20 milliseconds to take round trip. Okay, so this link I have 1 megabit per second, and for a bit to transfer and to get back acknowledgement, I need 20 milliseconds. Okay. So first I'm asking about what's the bandwidth delay product if the system frame are 1000 bit in length. So if this frame, I send 1 frame and 1 frame equal to 1000 bits. So using stop and wait automatic bit request, how many bits I will send in one round trip? I send one, the bandwidth is 1 megabit per second. The frame size is 1000 bits, and each bit takes 20 milliseconds for round trip to go and receive acknowledgement. Round trip, and it means from the sender to the receiver and from the receiver back to the sender. This is round trip. So how many bits can I send in this case? So and do it automatic bit request. How many frames I can send? So and do it automatic bit request. How many frames I am sending? One. I'm sending 1 frame only and wait for acknowledgement. And 1 frame take 1000 bits. So what I can send per time is 1000 bit only type. But is this the efficiency of the channel, or the channel can transmit more? Hmm. How we assess, how we evaluate the performance of the channel? How many the maximum data I can transmit through the channel, or I can fill the channel? The bandwidth delay product, if you remember, the bandwidth delay product is how many bits I can fill in the channel. If you remember the definition of bandwidth delay product, if I have bandwidth 1 megabit per second, So how many bits I can send it from the transmitter to the receiver. This is the multiplication of the bandwidth multiplied by the delay. So if this is a delay for one frame, so this is a delay for second frame, so third frame. So for example, I can fill this channel with three frames at once. This is the efficiency of this channel or utilization of the link. So the bandwidth delay product is the utilization of the link. When I multiply the bandwidth 1 mega multiplied by 20 milliseconds is the time taken for round trip. This is 20,000 bits I can fill in the link. To be the link fully utilized, I send in the whole link all the capacity is full or the bandwidth is full. I can send 20,000 bits. Okay, because this is the bandwidth and this is the delay. Multiplication of bandwidth and delay. This is the definition of a bandwidth delay product. Or how can I fill this link? From this 20,000 bits, how many bits I already sent using stop and wait? Only 1,000. So the channel allow me to send 20,000, but using stop and wait, I only send 1,000 because I am sending only one frame and wait for acknowledgement. So I lose the efficiency of the channel. So I could only send 1,000 from the link. This is what we call utilization percentage of the link. I used or utilized only 5% from the link because I sent one frame, but the channel can be filled with 20,000 bits. So can be sent with 20 frames. So the channel can accept 20 frames to be filled. Why I am only sending one frame using stop and wait automatic repeat request. So this is the main disadvantage of stop and wait automatic repeat request. If the link has a high bandwidth or long delay, and I am using stop and wait automatic repeat request, it means that I will waste the capacity of the link. The definition of utilization percentage is very important. Because usually when we access the call, I am asking about what is the utilization percentage of this link. Okay. Using stop and wait automatic repeat request, if the channel has high bandwidth or long delay, I will waste this capacity because I will send only one frame, whatever the bandwidth. If the bandwidth is very large, I only send one frame. And if the delay is very long, I will wait for the acknowledgement for only one frame. So how we can solve this problem بقى؟ الباندويث we need more bandwidth. It's better for us to have equal bandwidth. It's better for us. Yes, exactly. Here the bandwidth can accept how many frames? 20 frames. So the bandwidth can accept 20 frames, but I am only sending one frame. And this is advantage. So what about if I am sending 10 frames, for example, or 15 frames? Then wait for acknowledgement. Instead of sending one frame and wait for acknowledgement, I can send 15 frames and then wait for the acknowledgement. By this way, I can benefit from the available bandwidth of the link. Okay. So if we repeat it, the same example, but I am sending 15 frames per time, not before receiving the acknowledgement, not one frame. In this case, I will send 15,000 bits and the available capacity of the link is 20,000. So now I am using 75% of the link capacity, or the channel utilization or link utilization is 75% now. By only changing a small thing in automatic request is sending multiple frames instead of sending one frame before receiving an acknowledgement. So by this trick, we increase the utilization percentage of the link. Clear what's the disadvantage of stop and wait automatic request, or how can we solve it? And now clear what is the importance of the bandwidth delay product. maybe when you studied in chapter 3, I think, or chapter 4, you didn't realize what's the importance of the bandwidth delay products. Here's the importance of the bandwidth delay product. Give us the capacity of the link. So I can see how what's the percentage or what's the utilization percentage I'm already using from available capacity. By this small change, we moved to the third or second in the noisy channel, but the second protocol in the noisy channel, which is from its name, go back in. So I will go for any frames and wait for acknowledgement. Now I will send instead of one frame, let's do and wait automatic get request and go back in. I will send any frames before waiting for the acknowledgement. So I will not wait for the acknowledgement. I will send any frame. Then, if I didn't receive any acknowledgement, I will wait for the acknowledgement. I can send all the capacity, but in this case, it will be very challenging because if I am losing any number of frames, I can send to be 20, to be 5, to be 10, to be 15, whatever. I will decide. But n is number of frames that I can send before receiving acknowledgement. Okay. So in this protocol, we will send n frames before receiving acknowledgement. And for sure, we will keep copy of this n frames. Why? After sending these n frames, I have to save copy from these frames. Why? Yes, exactly. Because of retransmission. The same reason for stop and wait, but in case of stop and wait, I'm sending one frame and keep this one frame only. Now I will keep n frames. Because if I lose any one of them, or I didn't receive any acknowledgement, I will retransmit all n frames. In this case, the sequence number stop and wait automatic request sending one frame, the sequence number can 0 or 1. Now the sequence number will be 2 to the power m. What's m? M is number of bits used for this sequence number. So for example, if I used 4 bits to number these frames, I will have 16. So sequence number will be 16, so I can send from frame 0 to frame 15. Okay, so I can send from frame 0 to frame 16 to frame 15, then it will be 0 again to 15 and so on. This is a sequence number of frames. Okay, the sequence number here is 2 to the power m, where m is the number of bits used for a sequence number. If m equal to 4, the sequence number or number of frames, the frame can take any number between 0 and 15. Okay. In this case, we will name, we'll have two definitions here. Send sliding window and receiving sliding window. What we mean by sliding window? Now I will have any frame I need to send. Yes? So I will have window as a transmitter. I will have number of frames from مثلا frame 0 to frame 15. This is what we call it send sliding window. Okay. Well, why we name it sliding? Is because I here I started by SF indicator for the beginning of the window, and here SN is the next frame to be sent. And I am sliding this. I will send the first one, then sliding, then first, second, two, and sliding, and so on. So I will send once I receive acknowledgement for frame 0, I will remove this, and now the new window will be starting from 1 to 15 and the next one again. So I will slide the window. And I will slide this window once I receive acknowledgement. And if, for example, I lost the acknowledgement of 0 but receive the acknowledgement of 1, I will consider also 0 received. Acknowledgement for 1, if it doesn't, the receiver can send for 1, but I received one, I will shift both of them and I will start at the window. I will slide the window and so on. Okay? So this is the same sliding window, the same as the receiver side. I have part of window of the frame and I have the receiver. I'm waiting for this frame, for frame zero. Once I receive frame zero, I will slide to frame one. I'm waiting frame one. Okay. So now we have window of frames back. And instead of stop and wait, we have one frame, send, one frame, receive. Now we have window of the frames I can send. And this is the shape of the window. Now we have window starting by SF, اللي هو الفيرست outstanding frame in this window, and I can send for this and this example for example. And then send the next frame to be sent, but I will wait. So I can 0 to 6 without acknowledgement. Then I will wait for acknowledgement. If I have acknowledgement, I will shift the window and send SN. So now we has SF, the first frame in my window, the next frame that I can send after receiving acknowledgement, and طبعا ال S size is the send window size. Send window size is 2 to the power m minus 1. Minus 1 فوق. Minus 1 تحت. m minus 1. So if I have sequence 16, it means that I can send 15 free. So the window size is m minus 1. طب why minus 1 دي؟ لأن receiving window size is only 1. I will wait for the frames one by one. So I will wait. I will not receiving window. I will not wait for the receiver waiting for frame 0. I will wait for frame 0. Once I receive 0, I will check 0 and so on. So the size of the receiving window is 1. But the size of the transmitting window is 2 to the power m minus 1. فالسمشن هو 2 to the power m. What you want to know? Now we have sequence number between 2 to the power m. والm دي number of bits that I can use for the sequence number. الويندو سايز السند ويندو سايز would be 2 to the power m minus 1. وريسيفنج ويندو سايز هيبقى 1. يعني receiving window size here 1. I'm waiting for whatever I will move to size of the receiving window is 1. But the size of the sending window is 2 to the power m minus 1. I can send 2 to the power m minus 1 frame before receiving acknowledgement. Okay? And the send window can be slide one or more slot when a valid acknowledgement received. For example, I send with 06. If I receive the acknowledgement of 0, I will slide my window so the window between 1 and 7 now. Okay? So I can send 7. If I received بقى, if I lost the acknowledgement of 0 and all the three. Window between it will be between 3 and 8. I will shift 2 frames. Okay? And so on. So SF is the start of the window. The next frame and size is the size of the window, which is 2 to the power m minus 1. to conclude يعني what you need to know definition of SFF is the first frame in the window, definition of SL, the next frame I can send after acknowledgement, definition of send window size 2 to the power n minus 1 where receiving window size اللي هي will be 1. ف as I also remember you and also you make it wrong in the exam. And go back in automatic bit request when I'm asking what is the size of the send window and what's the size of the receiving window, it will be if I give you مثلا m equal 3. What's the size of send window? 7. For receiving window 1. طب لو m equal 4 will be 15 for receiving 1 also. عشان النكست هيبقى receiving بيختلف فهنا I'm asking m equal to 3 and sending window for receiving window 70% بيجاوبوا غلط. Okay. فريسيفنج window go back n always 1 والsending window 2 to the power m minus 1. Acknowledgement as I told you acknowledgement is are cumulative. It means once I receive the next one once I receive the acknowledgement of 2 it means that it includes the acknowledgement of 1 and 0 and all the previous. So it's accumulative. Okay. So I in this case I shouldn't wait for every acknowledgement for every frame. لا. Once I receive acknowledgement مثلا already acknowledgement خلاص. This is also advantage in this case. So if I lose some acknowledgement, it doesn't matter. لا why؟ لأن receiving window 1 and the receiving window unless مثلا I send 0 1 or 2 this is the one that I'm saying. So if 0 is dropped and I receive 1 Rn receiver and receiving 0. For 2 يبقى for sure the acknowledgement of 2. So receiver receiving window بقى is size of receiving window is 1 والRN is the next frame expected is the indicator the next frame I'm expecting. When a correct frame is received the window will be slides one slot. But here بقى ده يعني withdraw them because sliding window is the one. So I am receiving only this frame. I am waiting for only this frame. Any other frames, even if this frame are correct, but I will drop them. يعني even if I مثلا I miss 4, but I receive 5 and 6 correctly. Sender will retransmit 4, 5, 6 again. Even if I receive 2 of them correctly, but I have to retransmit all the window. Okay, so this is the design of the go back in. When the timer expires, the sender will resend all outstanding frames. So we'll send all the window. This يعني one of the disadvantage in go back in. If any of the frames is lost, so I didn't receive acknowledgement for this frame, so I will resend all the frames in my current window. And in this case طبعا instead of sending one frame and wait, in this case I will send acknowledgement, and the event will be the same specification for the sender, and at the receiver will be the same only when I receive and frame. So we'll have the same four events, but the only difference now is sending any frames, and we have sending window. Instead of sending one frame per frame, I will have a window of frames to be sent. Okay. For example, suppose that the sender has already sent frame 6, but the timer for frame 3 expire. Timer for frame 3 expire, it means that I didn't receive acknowledgement for frame 3. In this case, I will resend 3, 4, 5, and 6 again. Because I didn't receive for 3, even if I already sent 6 خلاص. But I didn't receive acknowledgement for 3. With timeout of 3 is expired. So I will resend all the frames 3, 4, and 5, and 6 again. That's why we called it go back in. Because if I have an error, if I didn't receive acknowledgement, I will go back in frames and resend all the n frames again. Yeah. Clear? Any question? Clear the difference between stop and wait, automatic commit request, and go back in? Because the questions of the midterm will always compare between stop and wait, automatic commit request, go back in. So you have to clearly know the difference between different protocols. Okay. Size of the receiving window is always 1, but size of the transmitting window is less than 2 to the power m. I didn't consider a window size 2 to the power m exactly and send all the possible frames. Because if we have مثلا then 3, we have from 0 to 8 frames, then from 0 to 8 again. طب why I don't send all 0 to 7 طبعا. Why I didn't send all the possible frames and I am sending only 2 to the power m minus 1 and I left one frame. This is the reason why I'm sending window size is less than 2 to the power m. Not exactly 2 to the power m, it's 2 to the power m minus 1. Yeah, because of this scenario. Here, m equal 2. So the number of frames 4. 0, 1, 2, 3. This is possible numbers of the frames. But the window, اللي هو 2 to the power m. That can make error if I consider exactly equal to the power n. If all acknowledgement received wrong, I didn't receive any acknowledgement. فlet's consider that sequence of go back in. Design without I will send 3. ولا ايه؟ So I will not send 3. So I will time out and all frames again. So all frames again. So I will resend 0 again. طيب ايه اللي حصل بقى في الريسيفر؟ الريسيفر كان receive 0 correctly. فشيفت 1 receive 1 correctly. shift to 2. And now he's expecting 3. طبعا ولا ده بروف. فهي waiting for 3. Now I will resend frame 0. discard. So and I will receive 0, 1, again. If the receiver in the next time receives the acknowledgement, it will send 3. So the procedure work fine because the window size. What's about if the window size is 2 to the power m exactly? So now I have frames between 0 and 3 and the window between 0 and 3. All the frame inside the window. Same scenario, all acknowledgement lost. I will send 0. A receiver received correctly, but I will shift to 1. To send the acknowledgement lost. Sender will send 1. Received correctly. I will shift to 2. The acknowledgement lost. Send 2. I will receive 2 correctly and shift to 3. Send 3. Then 3 now it's inside the window. So I will send 3. The receiver received correctly. I shift بقى لإيه؟ لزيرو. But the receiver, but the sender doesn't receive any acknowledgement. So what the sender will do? Resend. Resend all the window. I resend بقى إيه؟ والreceiver waiting for 0. But this 0 equal to this 0? No. فهنا بقى كام الايرورز بقى. If I make the window size 2 to the power m, I will resend the old 0, but the receiver is waiting for the new 0. And in this case, will make an error. The receiver will receive 0 correctly and consider this the new one. But this already retransmission. So the summation of the window size of the receiver plus the sender, send per receiver equal to 1, يبقى sender retransmission and the new frame. I if for this extreme case I receive all acknowledgement lost. This is an extreme case but may happen. I have to take care ان ما تبقاش all الويندو سايز تكون all the frames to differentiate between اللوس الريسند الريترانسميشن and new frames. This is the reason why the window size is 2 to the power m minus 1, not 2 to the power m. Okay. This is the code for go back in. It's similar to stop and wait, but now we have to define SW, the window size, 2 to the power m minus 1, SF starting at 0, and I will start sending SN equal to 0 at the beginning. I am stopping here, and I've sent the next frame, I will send also the same frame. So we'll start by 0, waiting for event, request to send. Now what we need to add is the window or window is already transmitted. So I have to check if my frame is to send and the current frame, the difference between them must be less than SW. أكبر من SW, it means that the window is ended. خلاص I sent all the frame and now the next frame is outside. If the frame is not and send the data and then shift the indicator to the next frame to send. Okay. So the only thing I need to check now is if the frame is inside my window, so I can send. If the frame outside the window, so I can't send. But this is a new condition added here. I have to check back for the acknowledgement. If I receive the acknowledgement correct, without corruption, and the acknowledgement is less than SN, it means that the acknowledgement is for the frames inside my window. So I will shift. I will delete the received frame. مثلا خلاص I am waiting between 0 and 3. I received ودي SF And now I send 0, 1, 2, 3, and SN مثلا in the 4, which is my window. So I receive the acknowledgement of 0, means that I will خلاص delete this frame, my window. So SF now will be from 1 والSN هتشيفت فالويندو هتبقى between 1 and 4 now. So I will shift SF will be SF plus 1 and I will stop the timer for this frame and I will next sliding. This when I receive acknowledgement I will slide my window. Okay. At the timeout بقى first we will start the new timer and resend all the frame inside my window. Clear؟ طبعا الكود ده يعني long شويه ان انتوا to remember ف I will not ask about remembering all the code but I may مثلا give you يعني 3 4 steps and ask about 2 or 1 steps only. يعني مثلا if I receive acknowledgement I will give how can what once I receive acknowledgement you have to delete the frame and make shifting for SF but I will not ask you to write all the code يعني. Okay because this is complex but stop and wait automatic commit request to stop and wait لا simple previous code كانوا simple but this code is a little bit complicated so I need to understand the steps but يعني not to remember all steps يعني but understanding each step how what each step means يعني. Okay when ركزوا ان ال SF less than or equal to the acknowledgement number I will لان ال acknowledgement number should be within SF and SN to shift the window. So the acknowledgement should be received for the current window. At the receiver side, I will wait for a data to be received. Once I receive a frame, if it's not corrupted, it will be similar to stop and wait, and I am receiving only, I'm expecting one frame. I will wait for this frame. If this frame is sequence number equal to so the receiving the code of the receiver is almost the same as stop and do automatic bit request because I am waiting for only one frame to be received. Once I receive this frame, sequence number is equal to the RN, the waiting number, so I will shift and send acknowledgement with the new expected one. Here بقى an example. So an example go back in this example case where the forward channel is reliable but the reverse is not. Okay, so I will some acknowledgement are delayed and lost. So how a cumulative decision can help with acknowledgement are received. So here I am assuming that I send frame 0, frame 1 get lost, then I will send frame 2, frame 3. Then I will receive acknowledgement 3 and 4. So the window side I will send 0, 1, 2, 3. Okay? But the acknowledgement of 2 get lost. Okay? But I receive 3 and 4. Will I make retransmission? Hmm. طبعا same case لو كانت في الستوب اند ويت اوتوماتيك ويت ريكويست كنت هعمل ايه؟ ريترانسميشن ل 1 لان الاكنولجمنت طب في جو باك ان ولا ميك ريترانسميشن because I lost one acknowledgement why yes exactly because I received also the acknowledgement of 3 and 4 so I will send I received acknowledgement of 1 so I will shift my window so now the window will be between 1 and 4 here I received the acknowledgement of 3 so I will shift all the window to start from 3 now the acknowledgement of 1 but I received the acknowledgement of 2 so I now 3 I will set for 4 so I will set 4 so the next acknowledgement will account for the lost one طبعا sliding هنا I received 0, I will shift to 1. I received 1, I will shift to 2. I will receive 2, I will shift to 3. I received 3, I will shift to 4. I take care about the Rn and then SF والتايم اوت طبعا if there is any time out. That is important to know the Rn, this if for the sending window. Okay? Because I may ask you about if I need to send 0, 1, 2, 3 frames and the second one acknowledged, the acknowledged second one is get lost. Draw the flow diagram and show Rn with Sn. I have to mark all this. Okay? So acknowledgement 2 is lost, but acknowledgement 3 serve as both acknowledgement 2 and 3. So acknowledgement 3, once I said 3, serves as the acknowledgement of both 2 and 3. Okay? Right. This is important note. The stop and wait, special case of go back in. When stop and wait can be a special case of go back in. يعني when go back in can be exactly as stop and wait. Okay. One. While stop and wait sending one frame. يبقى الجو باك ان هو ان الان ايكوال تو 1 لما السلايدنج ويندو بتاعته ايكوال تو 1 it will be exactly stop and wait automatic wait request. So stop and wait automatic wait request is a special case of go back in هو ان الان equal to 1. Okay. This by the way كان question في الميد تيرم وبرضه 80% غلطوا فيه. فالجو باك ان special stop and wait special case of go back in هو ان الويندو size is equal to 1. Okay. في بقى last example let's consider it next time إن شاء الله. Any question? Okay, thank you.